So, hello everyone, this is Hymavathi, working as an assistant professor in the Department of Science and Humanities, MLR Institute of Technology. Today in this session, we are going to discuss about the method find integrating factor. So, in the last session, we discussed the different methods of finding and integrating factors. So, and in this session, we are going to discuss about the method 5 of finding an integrating factor, and we'll see the problem on using the method 5 of finding an integrating factor. So now, let us see how can we use the method 5 of finding an integrating factor. So when we are using this method 5 of finding an integrating factor is, so first of all, you have to verify the given differential equation is non-exact or not. So once it is a non-exact differential equation, so if there exists a continuous single variable such that, so you have to verify this condition. So what is that condition here? So dou n by dou x minus dou m by dou y divided by capital M is equal to g of y. So this value should be in the terms of functions of y or constants. So if this value, that means dou n by dou x minus dou m by dou y divided by m is equal to function of y terms only, or sometimes the constants is also exist. So if it is the constants, then we have to find the integrating factor. Then how can we find the integrating factor? So if we are getting the functions of y only or the constants is e power integral g of y dy is an integrating factor. So this is the process to find an integrating factor if the given differential equation is a non-exact differential equation. So now let us see the problem. Solve y power 4 plus 2y dx plus xy cube plus 2y power 4 minus 4x dy is equal to 0. Then how can we solve this differential equations? And now see the steps to follow. The first of all, you have to verify this differential equation is exact or non-exact. Suppose if this differential equation is non-exact differential equation, then how can we verify this is non-exact? Dou m by dou y is not equal to dou n by dou x. So if this differential equation is non-exact, and now we are going to finding an integrating factor. So why we are using an integrating factor? By using an integrating factor, the differential equation is converts to the exact differential equation. Then how can we convert that non-exact to the exact? By multiplying integrating factor to the non-exact differential equation. Right? After reducing to the exact differential equation, we have to find the general solution. So what is the formula to find the general solution of exact differential equation? So integral m dx plus integral n dy is equal to c. So while finding integration on m, you have to take the terms y as a constant. So while doing an integration on n terms, so in this case, you have to take only the terms which does not contain x. So this is the condition on the first term of the integration and the second term of the integrations. So now let us see the solution of the given differential equation. So clearly this differential equation of the form m dx plus n dy is equal to 0, right? And now we have to verify this differential equation is exact or non-exact. So then how can we verify the non-exact condition is? So first let us take what is the m function and what is the n function. So here m is equal to y power 4 plus 2y and n is equal to xy cube plus 2y power 4 minus 4x. So here m is equal to y power 4 plus 2y and n is equal to xy cube plus 2y power 4 minus 4x. And now we have to find the dou m by dou y value and dou n by dou x. So, dou m by dou y. Then how can we get the dou m by dou y value? So, we have to do the differentiation partially with respect to y by taking x as a constant. So, here there is no x term in this function, and now we have to do the differentiation on y power 4 plus 2y with respect to y. So, the derivative of y cube is 4y cube plus the derivative of y is 1. So, 4y cube plus 2 is the derivative of y power 4 plus 2y. And now see the differentiation on n with respect to x partially, dou m by dou x. So, with respect to x we are doing a differentiation partially, and now see the differentiation value of this function is, so here we are treating y as a constant, y terms as a constant. So, here y cube, y power 4 is a constant, and now the x derivative is a 1, so that the first term is y cube plus, and now we will have to do the differentiation on 2y power 4. So, 2y power 4, in this there is no x term since this is a constant, so that the 2y power 4 value is 0. Then minus 4 is a constant, then the derivative of x is 1. So, this is equal to 4. So, y cube minus 4 is the value of dou n by dou x. So, once observe these two derivative values, right. So, here the derivative of m 4y cube plus 2 is the value. The derivative on n with respect to x is y cube minus 4. So, now these differentiation values are not equal, right. So, dou m by dou y is not equal to dou n by dou x. So, that clearly this differential equation is a non-exact differential equation, right. So, now we are going to find the integrating factor. So, in this problem, so now I am using the method 5 of finding an integrating factor. So, what is the method 5 of integrating factor is? So, what is the value we have to find out first? So, dou m by dou x minus dou m by dou y divided by capital M, right. So, what is the dou m by dou x? Here we got the y cube minus 4. So, that function we have to take here, y cube minus 4 minus dou m by dou y. So, here the dou m by dou y value is nothing but the 4y cube plus 2. So, multiply with the minus. So, we are getting the 4y cube minus 2 whole divided by capital M. So, here the capital M is nothing but y power 4 plus 2y. So, y power 4 plus 2y. And now we are going to do the simplification. So, whether we are getting the only the function of y or constants. So, this is equal to y cube minus 4, y cube is nothing but minus 3 y cube minus 4 minus 2 is minus 6 divided by, in the denominator take the common y. By taking the common y, so we will get y cube plus 2, right. So, this is also equal to, in the numerator take minus 3 is the common, minus 3 into y cube plus 2 divided by y into y cube plus 2, right. Now, cancel the terms of y cube plus 2 in the numerator and the denominator, it will gives minus 3 by y. So, see, observe here. So, dou m by dou x minus dou m by dou y divided by m is equal to minus 3 by y. So, that here we are getting only the function of y terms, that is, assume that is nothing but the g of y. And now we are going to find the integrating factor. So, what is the formula of the integrating factor? The finding an integrating factor is equal to e power integral g of y dy is the formula to get the integrating factor. So this is equal to e power integrate minus 3 by y dy. Right, and now we are going to integrate on minus 3 by y in the power of the exponential e power minus 3 integral 1 by y dy. Integration of 1 by y is nothing but log y. E power minus 3 into log y is the value of integral 1 by y dy. Right, and now you have to take this minus 3 is the power of y. So e power log y power minus 3. So we know that e power, so since we know that e power log x is equal to x. So now we are going to use this formula on this. So e power log y power minus 3 is nothing but y power minus 3. So and this can also be taken as 1 by y cube. So now this is the integrating factor of the given differential equation after using the method 5 of integrating factor. And now we are going to multiply this integrating factor to the given differential equation, right? So what is the given differential equation? Y power 4 plus 2y into dx plus xy cube plus 2y power 4 minus 4x into dy is equal to 0. So this is the given differential equation. So for this given differential equation, so we are going to multiply with an integrating factor. That integrating factor is 1 by y cube. And now multiply 1 by y cube into y power 4 plus 2y into dx plus 1 by y cube into xy cube plus 2y power 4 minus 4x into dy is equal to 0. Right? And now we have to multiply this 1 by y cube with each term of these factors. Right? So after multiplying with 1 by y cube, the first term becomes y plus 2 by y square into dx plus, so after multiplying with 1 by y cube of this second factor, this term becomes x plus 2y minus 4x by y cube into dy is equal to 0. So this is the equation exists after multiplying with the integrating factor 1 by y cube. So now again this equation turns to the form of n1 dx plus n1 dy is equal to 0. So now again we have to cross check whether this equation is exact or not, right? So here n1 is equal to y plus 2 by y square, right? And now n1 is equal to x plus 2y minus 4x by y cube. And now we have to find the derivative value, that is on m1 dou m1 by dou y with respect to y differentiation. So with respect to y differentiation, the derivative of y is 1 plus 2 into the derivative of 1 by y square. So derivative of 1 by y square value is minus 2 by y cube is the derivative. So after the simplification, we will get the 1 minus 4 by y cube is the value of dou m1 by dou y. And now we have to find the derivative on n1 with respect to x partially. So with respect to x, so here x derivative is a 1, we know that, right? The derivative of 2y is a 0 since the since it is a constant, right? So 1 minus 4 by y cube into the derivative of x is 1. So this value is 1 minus 4 by y cube. Now once observe that these two derivative values are similar, right? So therefore dou n1 by dou y is equal to dou n1 by dou x. So now this equation is a exact differential equation, right? So now we are going to find the general solution of this differential equation. So then how can we get the general solution? So by finding the general solution, so we have the formula is, that is integral n1 dx plus integral n1 dy is equal to c. So while integrating on m1, so you have to take the terms of y as a constant, right? So while integrating on n1, so you have to take the terms which does not contain x. So now see the solution. Integral, what is the n1 here? So this is the function m1. So y plus 2 by y square into dx plus integral on n1 dy. So what is the condition we have on n1? So the terms which does not contain x only we have to take. So what is the n1 function we have here? X plus 2y minus 4x by y cube. So in this n, so which of the term we have to take? Only 2y, right? So integral 2y into dy is equal to c. So now we have to integrate. So the first integration is with respect to x we have to do by taking y as a constant. Since here y plus 2 by y square is a constant. Integration dx is nothing but x plus 2 is a constant, and now the integration of y value is y square by 2 is equal to c, right? And now we have to write again the equation is xy plus 2x by y square. So here the 2 gets cancelled, plus y square is equal to c. So this is the required solution of the given differential equation by using the method 5 of finding an integrating factor, right? So today in this session we discussed about the method 5 of finding an integrating factor, right? What is the method 5 of finding an integrating factor? Is dou n by dou x minus dou n by dou y whole divided by m is equal to g of y, or the constant, and also the integrating factor is e power integral g of y dy, right? And also we did one problem on non-exact differential equation using the method 5 of integrating factor. So these are the topics we discussed in this session, right? Coming to the next session, in the next session we will discuss the applications of first order, first degree differential equations, first order and the first degree differential equations. In the next session we will discuss about the applications of the first degree and the first order differential equations. We have the two applications here. So one is the Newton's law of cooling, and the second one is the law of natural growth or decay. That's all the today's session. Thank you.